All right, so we need to do some more conversions, right? We need to be able to convert grams to moles, moles to grams. We need to be able to look at mole ratios, balancing, all this good stuff that a lot of people tend to try to run away from. So if we're trying to figure this out, let's look at a problem. Let's think about a problem. Let's look at the molar mass of something, just in general. As an organic chemist, first thing that comes to mind probably be something like methane. Methane is if you I see. Hold on. Nathan is CH4. Okay, CH4. Now, this 4 is a subscript. This tells me how many hydrogens there are, okay? So in this case, I'm a round. We're not going to use exact values, so we can keep the math pretty simple. So carbon has an atomic mass roughly around 12 grams per mole. Hydrogen has a atomic mass roughly around 1 gram per mole. Okay, do that if we have 4 of these and 12 of these. We have 12 plus basically 4. This should give us, if we do this times 4, this should give us 16 grams per mole. Okay, now other units we can use U, we can use AMU, and we can also use grams per mole. For calculations wise, we usually use this. You can also use another one, but we're not going to go into that one. So mainly we want to stick with grams per mole. Okay. So let's think about, say if I had 5 grams, or even better yet, yeah, that's fine, 5 grams of CH4. Okay. How would I convert that to moles? Okay. So I have grams and I want moles of CH4. Well, I need to think about this. So if I'm trying to go to grams to moles, I need to find a common factor that can be used to convert grams to moles. In this case, it is this unit here. The units tell you everything. It is grams per mole. We can use grams per mole to figure out that conversion. So the way I want to do this is I'm going to go ahead and do 5 grams of CH4. And I want to convert it to moles using molar mass. That's what we were calculating earlier, is molar mass. So we have atomic mass. So let's clarify that. Atomic mass, okay, that's individual atoms. Okay, if we're doing molar mass, this is a summation of atomic masses. Okay, so what we're doing right now, what we're using to figure this out is that we need the molar mass, the summation of the atomic masses to figure this out. So if we're going to do that, what we need to do is take this, which is going to be 16 grams of CH4, okay, per 1 mole of CH4. This is going to give me 5 divided by 16. Which is roughly 0.3125 moles. Which basically, if we, we could use significant figures in this and use 5 as the least significant digits, would be basically 0.3 moles. Okay, but when we're trying to figure this out, you always want to think about what is the question really asking for? What is the question really looking for? Okay, so let's look at another one. Let's just look at another molar mass of some sort. Remember, molar mass is the summation of atomic masses. So let's look at, say, for example, water. Okay, that's H2O. Okay, H2O. Now, same thing, we have 1 hydrogen, right? 1 hydrogen, which basically is going to be, let's remove that actually. 1 hydrogen is worth, rather, 1.0 grams per mole. And we have 2 of them, so it's times 2. And then we have essentially 1 oxygen is going to be 16 grams per mole, roughly. And there's only one of them, so it ends up being 18 roughly grams per mole. Okay, so you always want to look at how many do I have here. We can always do a countdown. Okay, I did times 2 because there were 2 hydrogens. All right, there were 2 hydrogens, so I needed to take its atomic mass. Remember, when you're looking for atomic mass, the atomic mass is going to be usually the largest number on the periodic table that you're looking for. So let's say, for example, carbon. That I can't draw. Let's see. Okay, let's say carbon. Okay, the atomic number for carbon, all right, we usually like to put this guy, we'll say something like, it depends really, depends on what book you're looking at, but we'll put 12 here, and we put, sorry, put 6 there, and we can put a 12 here, okay, and then basically this is its symbol, this is the atomic mass, and this is the atomic number. Now, of course, we're going to also, which if we haven't already, we're going to talk about what each one of these consists of as far as protons, neutrons, and electrons. But when you're looking at this is the atomic mass. Now, you may also see it written this way, depending on what periodic table you use. You may see the C here, you may see 12 and see 6. Remember, the larger number is always going to be atomic mass. Okay, that's always going to be the most important one that you need to look for, which is atomic mass. Okay, so do not ever use this number for any of your calculations unless otherwise noted. But for the most part, any of your calculations that deal with these guys here, any conversions, grams per mole, so forth, always use the larger number on the periodic table. Okay.